Hey guys, this is your presentation for Tuesday, November 10th. Make sure you fill out the attendance link to get credit for being here and doing the work today. Couple of reminders, you just got a new set of vocab assigned to you. It is due on Monday the 23rd, so make sure you're working on your weather tools and symbols vocab. We just took our quiz on weather factors and we do that in SchoolNet, so please make sure you have that completed, and if you don't, get it done as soon as possible. And then what we're doing today is going over our next set of notes on weather tools and symbols. So make sure after our presentation that you go over them and then turn it in. So go to the Google Classroom and open up the classwork tab. That's where you're going to find your template of the notes. So go to the classwork tab and pull out your template for the notes for today. The first set of your notes is review, just because the last set of notes was super long and had a lot of information in it. So we pulled a couple of things out to review with you guys. So the first is about high and low pressure systems. With a high pressure system, you have cold falling air. So you know that cold things are more dense and they sink. So with a high pressure system, you have cold falling air down the middle, and that air rotates clockwise. Because you don't have anything going up, any moisture, any warm air going up and making clouds, high pressure systems will show you good weather. Okay, they don't have any type of bad weather associated with them. That cold sinking air goes down and out. So no creation of clouds whatsoever. A low pressure system, on the other hand, deals with warm air, and we know that warm air rises. So in the middle of a low pressure system, you have warm air rising up, and as you go up in the atmosphere, that air cools down and it finds particles to condensate on, and it creates clouds and rain. So our low pressure systems are pressure systems that bring bad weather. These pressure systems rotate counterclockwise. So you can see here it's rotating counterclockwise. We also want to review fronts with you guys to make sure you really understand them. The first was the cold front, and we talked about how fast that cold air rushes in and it pushes the warm air up and out of the way. And with a cold front, it creates precipitation and storms, okay? When you have a warm front, it's the exact opposite. This time you have warm air advancing in. We know warm air always rises up, so this warm air mass pushes up and over top of a cold air mass. And with that, if there's lots of water vapor in the warm air mass, you're going to have rain. The stationary front is just that. It's stationary, not moving. So you have a warm and cold air mass meet, but this time neither one moves above or below each other. Instead, they experience a standoff, and where they meet at can cause extended periods of rain if, once again, there's water vapor stuck in that warm air mass. An occluded front is the most complex front because it deals with 3 different air masses. So you see here you have cold air advancing in, hitting another area of cold air, and pushing an area of warm air up and out of the way. So that warm air mass gets cut off and pushed up out of the way. Whenever this happens, you will have precipitation. Now for the new stuff, for the new set of notes. This stuff is going to be all about meteorology and reading a weather map and all the symbols that they use and the tools that they use to predict weather. So a meteorologist is someone who studies the causes of weather and then uses data to predict what's going to happen. So they look at maps, they look at charts, and they use computers to help analyze data and figure out what's coming our way. The first weather tool we're going to talk about is a barometer. A barometer measures air pressure, or barometric pressure. It means the same thing, okay? So you can have a mercury barometer or an aneroid barometer. This one right here with the chamber, you see this little chamber? That could be a mercury barometer. The mercury rises or falls based on the air pressure. So if the pressure drops, then the mercury drops. If it's high pressure, the mercury rises high. The other type of barometer is over here, and this is an aneroid barometer. An aneroid barometer is a barometer that uses not mercury, but it has a chamber inside that builds up pressure, and it turns the dial based off of how much pressure is found in the object. So the units we use are millibars, psi, or inches of mercury. You know that if we see low pressure or if pressure drops, that means we're going to have bad weather, just like low pressure systems bring bad weather. And then if you have high pressure and that pressure rises, we're going to see good weather. The next weather tool we're all familiar with is the thermometer. The thermometer measures your temperature changes, right? So it's measuring how fast those molecules are moving. If molecules are moving really fast and they're super far apart, we're going to have warm weather. If molecules are moving slowly, they're bunched together, that's when we have cold temperatures. The units that we use for thermometers are either Celsius or Fahrenheit. The next tool is a psychrometer, and psychrometers measure humidity. They do so with these two bulbs that you see right here. Here's a wet bulb. It has like a little piece of cotton that you dip in water. And then here's the dry bulb that does not get any water on it. You grab the handle right here and you sling it side to side, and these two thermometers measure different temperatures, and you subtract the two, and that tells you the amount of humidity in the air. We use the units for measuring humidity as the grams of water vapor per cubic meter of the air. So it pretty much tells us how much water vapor is in a specific area of the air. The next weather tool is an anemometer, and that measures the wind speed, so how fast the wind is moving, right? So we can use a variety of units for wind speed. You could talk about the wind speed moving a specific amount of miles per hour or kilometers per hour or even knots. So those are both or all three types of units that we can use to measure wind speed. Anemometers can measure wind speed and direction because it has sensors in it. It spins, and the way it spins is how fast it's going, and the sensors dictate the direction that the wind is moving. The next weather tool is a radar, and radars are electric instruments that determine the direction and the distance of objects that reflect radio energy back to the radar site. So the main thing a radar is used for is to see precipitation like rain or snow. The different colors that you'll see on a weather map show the strength of the precipitation and the physical phase of it. So is it in the form of snow? Is it in the form of sleet? Is it just liquid and in the form of rain? Another weather tool is the Doppler radar. The Doppler looks like this. It's on a big tower, has a big sphere on top. The Doppler radar detects precipitation intensity, so how hard it's coming down. It can detect wind direction and speed, and it provides estimates of the amount of rainfall that's going to occur. This is beneficial because it gives forecasts the ability to provide early detection of things like severe thunderstorms. The Doppler radar is one of the key things that lets them create watches in plenty of time so that we have time to prepare. Satellites and radars give forecasters the tools to provide accurate forecasts and give us that advanced warning. So next, let's talk about satellites. A satellite is a tool that is primarily used to monitor the weather and the climate. So instead of just focusing on what's happening at this specific time and place, satellites are also useful in collecting data to determine an area's climate. So climate is over a much longer period than weather is. So satellites can go as far as showing city lights, forest fires. It can show long-term effects of pollution, sand and dust storms, ice mapping, all of those different things satellites are able to do. And remember that our satellites float way up high in the atmosphere. Our ability to detect storms has improved because we have such advanced technology with our weather tools. And that advanced technology helps us detect storms and provide warnings well in advance. So now let's talk about some weather symbols that you might see on a weather map. We've already taught you guys the symbols for fronts. So you know a cold front is blue triangles because blue is always associated with cold. And a warm front is the little red half circles that look like little suns coming up on the horizon. And red is always associated with warm. Your stationary front shows warm battling against cold. And your occluded front shows your little warm air mass stuck in between the two cold air masses. Okay? A key thing to note with fronts is that the symbol points in the direction that the front is moving towards. So if the symbols, like in this cold front right here, they're pointing down, that means if this front was faced just like this on a weather map, it would be moving south. This warm front, would be moving north. So whichever way those symbols are pointing is the direction that the front is moving. All right, so for pressure systems, we've taught you guys this already as well. A big red L is low pressure and a big blue H is high pressure. That is because with low pressure, you have warm air rising up. And remember, anytime we use warm, it's going to be red. And with high pressure, you have cold air sinking. So that is why we use blue. Now, we also have specific symbols that we use for wind speed. So if you look at this symbol that you see here on the chart, you see a circle. That circle is going to represent the amount of cloud cover. The long shaft coming down the end is going to show you the direction that the wind is blowing. So you could say this wind would be blowing southeast. And then the little tick marks off the end represent how fast the wind is moving. So this wind speed. Like I said on the last slide, the circle represents the cloud cover. So if it's completely open and not shaded, it's a clear sky. And then if it's fully shaded, that means it's overcast, which means the 100% of the sky is covered with clouds. Okay, so the breakdown is by quarters here. So 25% means scattered clouds, 50% means partly cloudy, and 75% means mostly cloudy. So next we're going to talk about isobars. A key way to remember this is breaking down the part of the words. So the prefix iso means same. So isobars, the bar stands for the barometric pressure or the air pressure, right? So isobars are going to be lines on a weather map that show the same air pressure. So if you have the same amount of air pressure in an area of North Carolina as well as South Carolina, then you're going to have a line going through North Carolina and South Carolina with a number on it. And the areas that fall on that line are all going to be having the same amount of air pressure. The same thing for an isotherm, except for these are lines on a weather map that connect areas of the same temperature. Therm, think of thermometer, measures heat, right? So if you have an area, we'll say up here in Virginia, it looks like this line is 75 degrees. So anywhere on the weather map that's hitting 75 degrees, you're going to have a line crossing through those states or those areas that are 75 degrees. So that's what an isotherm does on a weather map. It connects areas of the same temperature. So using this picture here, we just kind of wanted you to see how the different symbols can be used on a weather map. This specific map is used to look at wind speed. So you can see that over here where you just have the shaft pointing in the direction, it's calm, 1 to 2 miles per hour, very, very little winds. But then you see over here by this low pressure system, you're getting a lot of little tick marks off the end of these shafts, which means your wind speeds are amping up, right? So that's how you read the different symbols for wind speed. For pressure systems, you have your big H up here for high pressure, and high pressure brings good weather, so you can notice there's very little precipitation around it. There's some clear skies. But then over here where you have your red L, you see a lot of things going on. You see some snow back here, some rain, some severe thunderstorms. So low pressure brings bad weather. And then here you see fronts. So here is a cold front over here at the bottom of California, and the cold front looks like it is moving southeast because those arrows are pointed kind of down into the side, so it's moving this way. This warm front right here at North Carolina is moving up because the symbols are up top, and this cold front down here is moving southeast towards Florida. So whichever way those symbols are pointing is the direction that the front's moving, okay? So notice right here around the low pressure and cold front we're seeing storms. Same thing for low pressure right here, and then these storms over here by your cold front that just came through, okay? So that is it for today. If you have any questions for your teacher, let us know and we will be more than happy to help.